Hello, my name is Cezar Barbalho. I'm an engineer, and this is the case of Metro of São Paulo, Point Clouds, a big project of a metro tunnel. So this is our schedule for this presentation. First, some acknowledgements. Some people that without their contribution and they help this presentation would not be possible. These people here, and also to all team members involved in this project. Solotecnica is a Brazilian company that operates globally in the development, management, and supervision of projects and execution of works on assets in the fields of housing, urbanization, basic sanitation, transport, energy, irrigation, and environment. I work for the Tech Lab. Tech Lab is the area of Sonotecnica that promotes and develops innovative, customized solutions that guarantee the best flow of information in the projects in which the company operates, integrating solutions from modeling, compatibilization and simulation, planning and control, collaboration and management, and also synthesis of projects for the strategic level of organizations. I already said that, but my name is Cezar Barbalho. I have a technician degree in mechatronics. I am also a production engineer, mechanical engineer, and I have a post-graduation degree both in railway engineering and being applied to infrastructure projects. I work for about 20 years in the land transportation field. I am very specialized in innovation, being interoperability, and also point clouds. Well, this case of application. This is about the extension of the line 2 green of the metro of the São Paulo city. This project is vital for the city because it's about a line of metro that is characterized of a perimeter line. It grants us access to the central of the Paulista Avenue. Paulista Avenue is a major commercial and financial site here in São Paulo. It is a region of the city with a high concentration of health, cultural, and tertiary services. The project of extensions, it aims to gives and enables integrations in the page area of the stations between two lines, the line 2 green that is being extended and the future line 20. It will increase the accessibility to neighborhoods in the region. And it will ensure the adequate level of service, increasing the offer of trains. The project, well, after Vila Madalena station, there is an extension of about 500 meters extension used for train maneuvers and parkings that ends at the street Juatuba. This case follows the generation and supply of inputs for studies and the project of, if needed, remodeling of the permanent way in the existing section. The company of Metro São Paulo, it has some preliminary requisites for this modeling. Here are some of these. Priority for modeling structures like the NATM, the emergency walkways, and the permanent way superstructure, mostly the rails. Maintain the accuracy of the modeling versus the point cloud in about 10 centimeters, enable volumetric extraction for the model, and make available it in IFC 4.3. Well, the workflow. Initially, the workflow was based in some traditional way. So we started by capture and processing the inputs. By inputs, I mean the point clouds from both LiDAR and from photogrammetry. Then we have the collection of reference drawings. Then we start the modeling over the reference drawings. Then we will attach the point cloud to the modeling software and make adjustments as needed be. Later on, we will do the quality control by visual inspections and virtual tours. Then, if all goes well, we will apply the approval and delivery of these inputs to the project area, so they can make the new project of the new section of the permanent way. Following our workflow, here is the photogrammetry capture. And here it is, the LiDAR capture of the tunnel itself. Well, following our workflow, next is an example of the reference drawings that the company made available to us to bring the model into Paris. Now we can see here there are some sections of the project of the tunnel and also the horizontal geometric project that dates back from 1978. This is the resulting model. As you can see here, there is nothing that stands out about the quality of the model. It's a solid model. But how can we sorry, I believe we can start again this slide, okay? 3, 2, 1. So this is the result of the modeling from the reference drawings. And as we can see, there is nothing that is really stands out about some issue. There is nothing that we can remark here about the geometries. It's a very good looking model. But how can we assure our client that our modeling from point clouds there he is really close to the real geometry of the existing asset or existing building, or in this case, existing tunnel. Well, for the quality control of this model, we start doing a virtual tour using beam coordination softwares. And we would make the tour looking very closely to the details to identify imperfections in the model. What happens is that this kind of work is time consuming and is not precise enough. What we can do in the traditional way is to take measurements from the points where the geometries are divergent from the point cloud. But there is no way to do this in an economic and even operational, in terms of operational speaking, there is no way to do this manually. So here in Sombra Técnica, we are applying what we call of dimensional analysis from macro scale with the model. In very short terms, we made our model into synthetical point cloud, and we run comparisons between the model and the original point cloud. Here is the results of the first batch of modeling. As we can see, although there was nothing that we can look and nothing that stands out in terms of poor quality at first, here we can see exactly where we need to do some rework. It's very hard to represent the imperfections of the NHM with the conventional modeling, because NHM is a kind of tunnel that is made by controlled explosions. So we have what we call underbreaking and overbreaking. These features, as we can see here, need to be represented in order to have the accuracy of more or less 10 centimeter for this structure. Also, we can here see that we have some incompatibilities between the project and the execution for the permanent way, mostly the rails. So the workflow that was composed of these 7 steps was revised, and now we have introduced 4 steps and have made 1 or 2 obsolete. Let's focus on what was new. Point cloud post-processing was introduced in the workflow. Expression of relevant geometric features, and also automate the modeling tasks, because it becomes very cumbersome to model these kind of features. And also, from now on, the quality control is made by this macro analysis. First, about the post-processing. The post-processing in our company is composed of decimation, classification, and segmentation of the point clouds. As you can see, the decimation for each category of elements is different because of the applications. The decimation aims to reduce the size of the file and the number of points, but maintaining the distinctive geometric features, so we can still model with the point clouds. Here we can see the NHM arcs are purple. We have the emergency walkways in red, and we have the permanent way and the signaling equipment here, they are green, and the tunnel invert is here gray. we can observe that each of category has a very own density of points. So this made our work more manageable. Also, here is an example of the extraction of distinctive features, like a series of sections and also a series of longitudinal sections. The automation in this work was carried out in two moments. One with Python for the manipulation of the point cloud using a free software, Cloud Compare. And so we can extract multiple information accordingly to our previous analysis of the point cloud that are made during the work of the post-processing, and later to bring this information in a more friendly way to the modeling software. In this case, is the Autodesk Sigma 3D. We utilized the dynamo also with some custom nodes of our own making. And here is the results. First, what we can see is that the exterior of the NATM now, it represents the underbreak and overbreak of the structure. Also, it was made from subassemblies and it was characterized their components. We have the lower side here with the various components of the permanent way. And we have also a more reliable representation of the structure of the emergency walkway. And here is the last result of this revision of the modeling utilizing this new workflow. Although our client has asked about 10 centimeters of precision, we are delivering under 5 centimeters of precision for these structures. And as you can see, we have achieved the goal of focusing and delivering first the inputs for our team of projects about the emergency walkway, the rails, and the ATM. So, in conclusion, by applying this method of quality assurance, quality control, and a new way of face the modeling of these linear structures, we have assured that we are complying with the pre-established goals that our clients and also our project team has set to us. Thank you. Muito obrigado.